subtracting positive and negative fractions. So in this, these are the rules for adding and subtracting fractions, and at this point we're including positive and negatives, and we're writing it with algebra. So in the first example, it has to deal with addition. We know that whenever you add two fractions together, you keep the denominator and you add the numerators. That's basically what that first example is saying. In the second example, whenever you subtract two fractions, you subtract the numerators and you keep the denominator. Only what we're going to start doing is changing subtraction to adding the opposite, just like we did when we were working with integers in our last unit. So if we go to the next slide, it tells us to use the integers to determine the operation, addition or subtraction, and then determine the sign of the answer based on adding integer rules. So I actually always start out and do number 1 and 2 before I actually do any math. So first, we're going to use integers to determine the operation. So we have 5 1/4 minus 2 1/3. Well, 5 1/4 is the bigger one, minus 2 1/3. This is actually just a regular subtraction problem, but I'm going to go ahead and change it to adding the opposite. So I'm going to change subtraction to add the opposite. Now, one thing to keep in mind is that the entire value of 2 1/3 is negative. So it's not that the 2 is negative or the 1/3 is negative, it's the entire value. Because if you think about it as an improper fraction, that's really just 7/3. So it's negative 7/3. Only we leave it as a mixed number whenever we're dealing with addition and subtraction. So just think about it as the entire value, 2 1/3, is negative. So we need to think about whether we're going to add or subtract. Well, since we have different signs, we're going to subtract. And then we're going to determine the sign of the answer based on our rules. Well, we have more positives than negatives, so our answer is going to be positive. Well, now that we've determined what to do, subtract, we can go ahead and subtract. And I like to write down my sign for these because it's so easy to forget what the sign is by the time you finish the problem. So that's why I put the positive. Now I'm just going to approach this as a regular problem. So I'm going to get my common denominator. I'm going to multiply by 3 over 3 in my first fraction and multiply by 4 over 4 in my second fraction. And in doing so, I end up with 5 3/12 minus plus negative 2 4/12. I'm going to have to borrow. So I end up with 4, and I'm going to add 12 over 12 to my top fraction. So I end up with 15/12. And 15/12 minus 4/12 is going to be 11/12. And 4 plus negative 2 is going to be 2, and I'm going to double check the sign, which should be positive. So my answer is 2 and 11. In this example, we have 3 numbers, and we have negatives, subtraction, and addition. So the first thing we need to do is what we always do. We're going to change all of our subtraction to addition so that we can be clear what the signs are on each of our numbers. The next step is to work with our order of operations. Now, one nice thing about changing everything to addition is actually it doesn't matter what order you add things in if you have all addition. If we had multiplication or division mixed in here, then it would matter. We'd have to work left to right doing multiplication and division first. But since it's all addition, it really doesn't matter what order you add things in. I'm going to go ahead and work left to right because that's what a lot of you guys will do. So I'm going to start. You have to add just 2 at a time. So I'm going to start with adding negative 2 1/3 plus 2/3. Nice thing is these two already have common denominators, so we don't have to deal with that piece. We do need to think about our integer piece. So we're adding a negative and a positive, which means we're actually subtracting. Whenever you add different signs, you're actually subtracting. We have more negatives than we do positives, so our answer is going to be negative. So we have a negative answer. So we're going to subtract these two, and our answer is going to be negative. So I have 1/3 minus 2/3. Can't do that, so I'm going to have to borrow. So that becomes a 1. I add 3/3 here, which gives me 4/3. So 4/3 minus 2/3. Remember, we're subtracting because they're different signs. 4/3 minus 2/3 equals 2/3. And 1 minus, there's an understood 0 here for the whole number. So 1 minus 0 is 1, and it's a negative answer because we had more negatives than positives to begin with. So we have finished finding the sum of negative 2 1/3 plus 2/3. Now we need to add negative 5 to negative 1 2/3, which was our answer to the previous sum. So I'm going to add negative 5. So we need to think about our signs and our operations. Since we are adding two negatives together, when you add same signs, you actually do add. So we are going to be adding these two fractions, or mixed numbers, and the answer is going to be negative because when you add negatives to negatives, you just get more negatives, right? So we're going to end up with a whole bunch of negatives. So now make sure you understand that when you don't have a fraction, when you have a mixed number, as one example, like negative 1 2/3, and then you have a whole number, that there's an understood fraction there, in this case of 0/3. So you're just adding 2/3 to 0/3, which gives you 2/3. You're adding negative 1 to negative 5, which is negative 6. And you don't have to show that 0/3. A lot of you guys already know this, but I'm just helping to fill in the blanks in case you don't. So our final answer is going to be negative 6 2/3. So we added because they had same signs. We have a negative answer because we were adding negatives to more negatives, which gives you negatives. Next, we're going to talk about fractions with variables in them. And this is where we get to make sure we really get the idea of adding numerators and keeping the denominator. So in our first example, we're going to be adding b plus 5 and keeping the denominator of 6. So we add our numerators and we keep our denominator. In this case, our denominators were already the same, so we just added our numerators and we kept our denominators. You can't do anything else because b and 5 are not like terms, so you cannot add those together. So that's our answer. In the next example, I'm going to change this to add the opposite. So in this case, again, I'm going to add the numerators, and I'm going to keep the denominators. So we're going to add the numerators, so we get 5 plus negative 3 over g. Now we can add 5 and negative 3 together because they are like terms, they're just constants. So 5 plus negative 3 is 2 over g. In our last example on this page, we have 3b plus 1/2. Now here we're going to have to get common denominators, so this one's a little harder. So what we're going to have to do is multiply 3b times 2 over 2. 3b is over 1. It's a whole number. It basically means 3 times some number. So we have to put that over 1 and then multiply by 2 over 2, so we'll have a common denominator of 2. So we end up with 3b times 2 is 6b over 2 plus 1/2. 6b and 1 cannot be added together and simplified because they're not like terms. So we just write it as 6b plus 1 over 2, where you're adding the numerators and keeping the denominator. For our last problem, we have 2x over 3 plus x. We need to get a common denominator. So you want to first think about what the denominator is of x. And that denominator is 1. Then you want to think about what to do to get common denominators. We're going to multiply x over 1 times 3 over 3 so that we'll have a common denominator of 3. So we end up with 2x over 3 plus 3x over 3. We're going to add the numerators and keep the denominator. So 2x plus 3x can be added together. They are like terms, so we get 5x, and then we keep the denominator of 3.